for those of you who stuck around for the second session, we're going to talk a little bit more about a hands-on introduction of Liquid. We're going to give you some chances to actually use the APIs and do a lot of the powerful features that are in Liquid. So if you were around for the first one, Alan Pichella, Director of Product. I've got Lawrence Nahum. You want to introduce yourself, Lawrence?
Yep. So my background is in computer science. I worked in finance for about 10 years at a company called SwapSwire, which was then acquired by Market and then joint ventured into MarketServe with DTCC. Around 2012, I discovered Bitcoin, and I saw very interesting use cases in terms of improved security on top of Bitcoin using multi-signature. So in 2012, I started working on a wallet called Green Address, now Blockstream Green, with a number of advanced features using multi-signature and sorry, I think that's right. And since 2015, I've been working at Blockstream, now as a chief architect as of October 2018, I believe. That's it.
Cool. All right. So what we're going to do, just quick Blockstream overview. I'm going to skip the Liquid overview because I think we've got a lot of the same crowd here. We're going to really get into the weeds of how Liquid actually works and how it does some of these things. Like, how does it do the two-way peg? How does it sign blocks? How is it actually, are you able to transact with it? And then we're going to create some assets at here as well. All right, so really our motivation, I jumped ahead here. We're trying to reduce the need for trust, and we're also trying to improve financial privacy. So a lot of the financial system that exists today relies on this trust in creators, trust in of assets, trust of custodians to protect those assets for us, trust in the markets to actually operate fairly. And a lot of these problems are solved by finding someone that we trust. And they don't necessarily need to be. So this is something where there's a big potential with a lot of the technologies that we're working on, what really motivates us. And the other part is improving financial privacy. So much of our lives is broadcast out to the public right now. And we want to be able to make sure that we can actually be private, but still have that verifiability that things are correct, and that we can share information with only the people that we want to share it with. So Lawrence, you want to just give 30 seconds on just kind of these are some of the big projects we're working on?
Right. So I'll start with Liquid. Liquid, we already went through. It's a sidechain of Bitcoin. We got Blockstream Green, which is a wallet for Windows, Mac, Linux, Android, and iOS. We got our data feed, which is reading all the pricing information from all the exchanges. We got Blockstream Satellite, which is a system we use to broadcast Bitcoin blocks, and in the future Liquid as well, anywhere in the world. We got Lightning Network, which is layer 2 on top of Bitcoin. We got Explorer, which is an open source Explorer that we recently released. And we got Simplicity, which is a smart contract language designed to be easier to prove and easier to reason with.
All right, so if you're planning on doing the hands-on part of this exercise, go ahead and you can download this at the Elements project under Elements. Is there going to be just some confusion? It's called Elements, but the binaries are, for the most part, Liquid. I think for the Windows ones, they're still called Elements, though. So if you go to this GitHub site as well, you can also look at the exercises, and it'll give you kind of the step-by-step based on what operating system you're on. And again, you can go to this and visit this anytime after this session as well, and do it from at home. And there's even some more challenging exercises that we probably won't have time for today, but we'll let you create your own Liquid Federation if you wanted to. So really get into the nuts and bolts here. So we talked about the introduction before, the idea that you peg Bitcoin in to the network, and you can have 1-minute blocks, confidential transactions, and confidential assets. They can move in and they can move out. And we're going to talk about how that actually works. All right, so now if you came for the technical code content, this is where we're really getting in the weeds. The first thing Lawrence is going to walk us through is the idea of the two-way peg. And so what we really have is a federation that has a wallet that is each one of the 15 members each hold a key to that they can be able to spend. So this is actually the script for the federated peg. Lawrence, you want to kind of walk through what this actually means?
Right. All the full nodes have this inside of them, so that they know who can sign these blocks. They know who are the 15 functionaries. They got the public keys of the 15 functionaries and of the 3 emergency keys. And it looks a lot like Bitcoin transaction script, but this is applied for blocks.
Yeah, so this one in particular, what it's doing is there's 2 conditions that the Bitcoin that are pegged into the network can be spent. So the first one is 11 of 15 signatures can spend this Bitcoin at any time. Now they're restricted based on the hardware that's enforcing this network, that those will only be paid to a whitelist, and they'll only be paid if someone actually burns an equivalent amount of liquid Bitcoin. And so what this does is you have 11 of 15 keys that are provided by the functionaries when they configured the network. Or, let's just say, 5 of them exploded, or there was a terrible disaster in some part of the world. If we didn't account for that, all those Bitcoin would be lost forever. So we have what's called an emergency condition here. So this is where we have, if you see the number 4032 in there, that number happens to be 144 times 28. 144 is the number of Bitcoin blocks on average per day. So this means after 4,032 blocks, that a different condition now is available to spend these coins, and it's 3 backup keys that are secured around the world in various vaults. So as long as the Federation's operating and spending those Bitcoin regularly, which it's scheduled to do, those funds are secure. If the Federation stops working, the backup keys can be retrieved, and as long as 2 of those are secure, the funds can now be returned to anyone in the network or sent to a new Federation that replaces the old one. So the next part is block signing. So it's kind of similar here. I made a much simpler version here of a Federation here. But the block signers they can be different Federation members, but in this case for Liquid, they're all the same. And they're actually provide this key, and they're configured into the nodes, just like Lawrence said, to define who can create blocks in Liquid. So there's no mining, there's no proof of work. If this is the example here, it's a 2 of 2 multisig, and this is actually put in the block header in place of where how the mining check would be. So you say, is there a signature that has 11 out of 15 of these valid? Then it's a valid block. All right, so now we get into kind of some of the real magic of how Liquid works. So this is how do you actually send Liquid Bitcoin into the network. So the challenge here is, if I want to send money to the Federation, how do I prove on the Liquid side that I actually was the one who sent it? And that's not an easy problem to necessarily solve. So we solve this with a method called pay-to-contract hash. So Lawrence, do you want to give a little bit more detail of how this actually works?
Right. When you send Bitcoins to the Federation address, you're actually the one creating the address itself, and your address on the Liquid side, or you're committing inside this address enough information that allows you, once you're on the Liquid side, to prove that it was you that sent those coins to the Federation. The Federation actually doesn't know that you sent them coins on the Bitcoin side until you go on the Liquid side and claim them, which is when you tell the Federation where the coins are and that it's yours.
Yep. So the analogy I like to use for that is, imagine you had 100 acres of property in the middle of Alaska that no one had any kind of monitoring or knowledge of. And you went out and on 1 square foot of the land dug a hole and buried a gold coin there. So how could I prove that that was my gold coin? What I could do is I could go broadcast to the world a map saying this is exactly where I find on this property the gold coin. And if someone digs a hole there and they find a gold coin there, they can be pretty sure that I'm the one who sent it there. So this is what we're actually doing. We're committing to an address on Liquid for being able to spend that, that receives that coin by sending it to a new address that the Federation didn't even know it had until we tell them about it. So this is what we do here. We modify the key by this hash for each of those keys, and there's a whole new address every time someone pegs into the network. And built into that, you can prove you were the one who sent it there. All right, so we talked about confidential transactions being one of the key parts of Liquid. So this is the ability to commit to a value of an output without revealing exactly what it is. So we do that. Lawrence, you want to dig a little bit into the weeds here?
A little bit. Right, so we do this to hide the values, but this is not enough to what you want is also to prove that you don't have negative values as well.
Well, then we'll get to that one in
okay.
the next slide. But yeah, you want to prove that what you're spending is what everyone's receiving. That's the most important part.
So you're using rinse and pinch or so?
Oh, Jimmy's asking me to bring in the heat, but fortunately we brought the expert on this topic here, Adam. So
it's a range proof. Okay. So
well, how's the how do we know that the inputs equal the outputs?
You're using the same thing that
it has homomorphic addition properties, and you use a range proof to prove that. So it's easy to prove it adds up. Just add it up. The remaining challenge is to show that there are no negative values that make it add up, and use the range proof for that.
And we'll get to that in the next slide too. But so basic idea is I can prove that by doing these operations on it through math that Adam understands that we don't, and trust Adam on this one. Basically, you can add these two obscured values and.
What's the, assuming you're using the SEC-P56K1 code, what's the H point that you're using for the Peterson?
It's generated with a nums approach, so it's just like a hash of G and a constant.
Num stands for nothing up my sleeve.
Yeah, coerced into a point of the curve.
Okay.
And then you know that couldn't be known because G it commits to G.
Okay, so you're taking like a hash of G or something like that.
Yeah.
Okay.
All right.
That makes sense. Great.
Now Jimmy is ready to update his new book,
Understand it better. If you
Building on Liquid, right? He's going to write a whole new book on Liquid next. We need to convince him. All right. So yeah, this is the idea. We can validate these inputs equal the outputs. All right. So does anyone have laptops? Anyone actually run this exercise or not? If you are, I don't know. If there's not that many people doing it, we can kind of power through this and let it go. At the end, we can do this live. But yeah, the next exercise is how do we actually configure and run Liquid. So I did this already, and so I can kind of show you what happens here. And so I started our Liquid Qt Liquid Core application. I configured it with saying that I'm going to get 100 million free coins. It's the denomination of Satoshis, and that it's going to be a test environment. So that this means it's not going to require any signatures for a block. So for signing blocks, all you need to do is create a block, and it's accepted in the network. Since this is only running on my computer and not shared anywhere, we don't really care about that. So now we have in here a wallet balance of 1 liquid Bitcoin. So this is what you should see if you follow the exercise. I think the exercise might have you create 10 instead. And it doesn't show any other assets. And you can see that this little mining logo is on here now. It says that it created this asset. This is from the initial free coins parameter that you can set. And now you see that it was sent to your wallet here. So that's just kind of a default. So you can start with something if you're playing with things for testing purposes. You don't have to create a Bitcoin node and do a peg-in if you just care about testing things on Liquid. If you want to do a full peg-in, you can do that as well. You just need to link your Liquid node in there. And so we actually do have that as one of the challenge exercises if you are going through there.
Yeah, although keep in mind you will have to wait about 102 confirmations on the Bitcoin side before you'll have your Bitcoins pegged in.
If you do it on RegTest network,
if you do it in
it's 10 bucks.
Yeah.
I think, unless it changed since last time I did it.
You're side chaining off of your own reg test right now?
Right now, there's no peg. It's like looking for a peg. I actually did disable pegging as well.
Okay.
Checking.
Okay. So no peg.
Not right now. We're keeping it simple.
Okay.
But it can. I've done it. Try. And if you do the exercises, you can too.
I'll try it after.
Jimmy will try it. All right. So if you want to keep working in the background while we're going on to the next ones, if you're wanting to do that, we condensed this a little bit. So we can keep moving on here.
And we can maybe issue an asset on.
We will. So confidential transactions. So this is what Adam was getting into, and Florence about the range proofs. So knowing two things add up is one thing, but it allows you to cheat the system if you are clever. So Lawrence, you want to dive into why range proofs are needed?
Yeah, I mean, Adam just mentioned it, and I mentioned it earlier. You want to avoid, you want to prove that there's no negative values being added up, because then you can you can cheat the system basically, and you wouldn't be able to see it because of the confidentiality. So with this, you can have confidentiality as well as enforce the good rules.
Yeah, exactly. So in this case, let's just say I created an input in my transaction that had 10 Bitcoin. I could create two outputs for it, one that has 15 Bitcoin and one that has -5 Bitcoin. And that -5 Bitcoin isn't really a debt anyone can go collect from me. It's just a UTXO that sits there. And I can just throw it away, forget the private key to it, and pretend it never exists. And everyone's going to think, what's that?
You're printing your own money if you have a negative.
Exactly. So I now have an output with 15 Bitcoin that I created with 10 Bitcoin. So now I've created money out of thin air. So we need to make sure none of those are zero. Or I'm sorry, none of those are negative. We can make zero. That zero is okay. So as long as we make sure everything is non-negative, we can't do it anymore. So in this case, how do we prove this? In the simple case, we created X liquid Bitcoin being spent. We had an output with X plus Y. We had an output of minus Y. As long as Y in this case is negative, which means that the second output is positive, then we can prove that no output is greater than the input. So this is done through the range proof. You want to dive into the range proof is basically proving without revealing the amounts, but still being able to prove that it's greater than zero for each output.
Yeah, it allows you also. Yeah.
All right. So that's going to lead us to exercise 2. I'm going to walk through this, and then if anyone else wants to do this as well, again, the instructions are here on the GitHub. I'm going to be moving. If you go to github.com, if you want the binaries or the exercises, it's github.com/blockstream, and then I think it's like Liquid Consensus 2019 or something. Yeah, Liquid Walkthrough. There you go. All right, so here we go. We've got the Liquid node here, and we actually want to learn about these addresses. So, I gotta make sure. It's hard to see exactly where this window is here, and I don't know how well you all can see this font on this screen here, but I think I can make it bigger. Oh, look at that! It's gonna be gigantic. All right.
Yep. Yep.
So I'm typing in get new address, and that's going to get me, what did I do? Did I spell it wrong?
No.
I put an extra S on there.
Yeah.
It tries to help me here. All right, so you can see this address here that's being created. It looks very big. And the reason is, it has two parts to it. One is the actual,
Is that base 58?
it is base 58.
Yeah.
But it has the normal address you'd think of for something like Bitcoin, but also a blinding key. So when I send that to someone, they can encrypt the amounts that only I can see what they actually are.
Yeah, and the confidential part of the address is never ending on the blockchain.
All right. So I can send liquid Bitcoin to this address. I'm going to send half a coin to myself. And there's a transaction for it. And what I'm going to do is actually look at what is in that transaction from the perspective of someone who is,
Up and pay.
all right. I'm going to put the ID in here.
Yep.
1. All right, so this is, and it's, I need to find the scroll here. The problem is the TV screen is not quite in the right spot, but I can scroll up here. Come on down. All right, so this information right here is that range proof we were talking about. That's actually the full transaction. And there we go. So we can see an input here. This is referring to what we're spending. And then the output, normally in Bitcoin, you would see something here that would say value. And that's going to show you the amount of the transaction. But instead, we have a value range, which is where you get the name range proof. So you're seeing it's somewhere in the range of 1 Satoshi and 688 Bitcoin. That's all I know.
Yeah, and also unlike Bitcoin, where you usually have anything that it's not part of the output you're sending goes to fee. With Liquid, you have a specific output just for the fee, which is different.
Can we see the signature for this? Because I know range proof signatures are pretty big.
Yeah, so you can see that's one output. One of them is the change. You can see that the address here is a shorter address now because this is the part that's just the.
That's 2 to the 36 times whatever.
And then there's the last output, which is actually does have a value because it's the fee, and that's explicit and non-confidential. So Jimmy wanted to see the. Is the signature in here? But you still have the whole hex of everything, and you can see.
Signature right there.
But that's the whole transaction, and so there's a lot of this range proof in here.
Wow, that's yeah.
It's
I
massive.
feel an arrow for some reason.
All right. So now we're going to do. We're going to actually get. I need to actually copy that address from before. There it is. So there's the address that we had before. We do get address info, if I spelled it right. And we're going to learn about what this address actually has in it. And so you can actually see.
No amounts.
This is just the address. So it's telling me, that's the address. There is the non-confidential part. I think let's scroll down a little bit.
So you can't go to an Explorer and find out what's. You could, but it's a wish list.
Yeah, you could. Yeah, you could in this case. So actually, you could in the Explorer because that address has the. You could type this get address info into any node and figure out what is the unconfidential address of it. So that's how Explorer works.
Yeah, well, so it's very trivial given a confidential address to extract the script up key or to extract the address that it's going to end up on chain. Like.
Okay.
And that's where that XU3QP, and that's the same thing we saw in the last transaction.
But within Liquid, you're not going to be able to tell like transactions and what their values are.
You don't, yeah, correct. So the transaction itself has no value.
This is the not the onboarding, but the offboarding from Liquid transaction.
No, this is an address info.
This is just within
Oh, okay.
within Liquid.
So if I looked at a block explorer for that address, all I would see is there's a transaction with it in it. I have no idea what was sent to it or how much. So that's, and then I could also, if I wanted to for time, I'm going to skip, but I could just send directly to that address. And you would actually, if I just sent to the unconfidential part, it would show up on chain as with that value there. And we'll skip that for right now. All right, so you want to talk about issued assets?
Sure.
Yeah.
Right. You can create assets. You can create assets in various different ways. You can create them confidential or non-confidential. This means that if you create an asset that is confidential, you cannot see how many of that asset have been issued. Well, if you issue it non-confidentially, then you can see how many were issued. Now, you can make an asset reissuable or non-reissuable. This is something you could also change later if you make it reissuable at the beginning. You can then burn your reissuance keys, proving to everyone that you cannot reissue anymore. Obviously, if you make it non-reissuable, you cannot make it reissuable later. And what else should I go through?
Yeah, no, we'll cover more later here. So reissuance, this is a concept, sometimes can be confusing. Basically, when you create an asset in Liquid, you have the ability to create the reissuance token. And so this means anyone who owns this token can create more of that asset. So you don't have to worry about sharing, hiding that information for anyone. It's just like any other token you have. And one of the tricks is you could also put conditions on it similar to any other Liquid transaction. So if I wanted a token that we could create more only if myself and Jimmy agreed, we could make a multi-signature reissuance. And the only way we can do this is if we both sign off on creating more. So that's very powerful for things like assets, like if you were doing a security token or a stable coin, you might want to have a board member or a senior, set of senior people to sign off on this, or an auditor, and it can require all of those things to spend. And all this is done very trivially. You don't have to create a smart contract for anything to do this. So we're gonna, the next exercise is showing how easy it is to create an asset in Liquid. So this is actually one of the faster demos to do here. So we're going to do this real quick. I'm going to do an abbreviated version of it. So if we want to create an asset, did I spell it right there?
It looks like it, but if you press enter, then it will show the help as well, which is convenient.
So I want to create an asset that has 10 Satoshis worth of it. And I want to create, I don't want it to be reissued. I can do 0. And let's press enter and see what happens. So now I have in my wallet
if you go back,
transaction. I'm going to do one more thing. I'll just generate 5 blocks just so it looks better on the wallet. And I'm going to bring back my wallet screen here. And what you don't see on my screen is a little alert now that I have 10 Satoshis of this asset. So now that's now in my wallet. And I could potentially send that to someone else. I'm going to do one more thing here. We're going to create it with a reissuance token this time. I need to put a leading 0 here.
Yep.
I'm going to do another thing here. I think this is the right API call. All right. So when I put that false there, you can see the help here, see what it does. That's going to see whether we're going to blind it or not. So when I created that, it's not blind. The first one, the only people who know how much that asset was created was me, or anyone I shared that blinding information with. The second one, everyone in the world can go out to their blockchain and see exactly how much of that asset is in there. So if you want to be private about it, you can. If you want to be open about it, you can be open.
Now, when you do confidential issuance or confidential transaction, you can always selectively disclose, prove to others this information. So if you want to show to someone that there are, to an auditor perhaps, you can share the blinding keys, and that would allow them to see this data. So you can choose who can see this data.
All right, so let's look back at the main wallet interface here. We can see now that there's 2 more assets. Unfortunately, because I did the same amount, you have to go back to the history to know which one was which. But I have 3 assets now in the wallet. There's the 2 that we created, and then there's the 1 reissuance token. So now, because let's talk about sending one of these first. So So first thing, if I want to send one of these assets, let's just see how to do that. So I want to get new address to be able to send it. And then I want to do send to address. Do I need to put in quotes, Lawrence?
Sorry?
Do I need to put in quotes or not? It's
I
good
don't
here,
think
right?
so.
Point. I know I'm going to miss one of the parameters here. Let me,
Well, you can use the help again.
yeah. Scroll here and just I have the instructions here. There we go. 1, 2, 3, 4, 5, 6, 7. I'm going to send 1 Satoshi of it. I have to add some extra parameters here so I can specify what asset it is.
So it's like guess the number of beats in this chart.
I don't know what
That's it, Eddie.
what's that? Oop, that's not right. That's a problem there. I don't know what that is. Oop. Just trying to delete this one. Oh, shit. Let me figure out I missed a parameter here. Let me see what it is.
Yeah, just print.
Oh, there we go. I have to put it in quotes.
Unset.
Yeah. New feature of Liquid 017. What am I doing here wrong?
I cannot.
It's hard to see the parameter here.
Yeah, maybe.
Let's just do it from this other way, right? So we can pay to this address.
Oh, that's the
I hope that's the wrong thing here, but
asset type.
all right, let's do this. What that's actually going to do is the same API. I can send.
Are you sending the token to an address right now?
Yes.
Can I ask you a question before that? Like, maybe you covered it already.
Yeah.
But can you create some assets?
So all assets are going to be independent, and you just have to treat them as different asset. They have different
Yeah,
IDs.
assets are not related to each other.
Okay, so one asset can't be a parent of
No.
other assets. Okay.
All right.
But you can reissue.
Correct.
If you set up yourself to be able to reissue, yeah, for example, if you make an asset that is
That's also
non-reissuable,
transferable, which is kind of crazy.
Yeah. So that you can do that. I figured out the problem here. So
Yeah.
I should copy paste this. Just one. There we go. I missed one parameter in there. That helps to read the documentation. So I was able to send another Satoshi of that same asset to myself, and it showed up. And I'm going to just do the get raw transaction here as well. Bunch of hex showing what it actually is. And this is what it looks like to the public. So in my wallet, I can see everything.
It's also possible to burn assets.
Absolutely.
Yep.
There's a
Address.
burn asset,
there's an
API
API
for that.
call.
and that's provable to anyone. So we can actually, like, if you lose your private key, that's kind of burned, but
Company would like to repurchase their own shares and then destroy them.
exactly. So if you're doing something like Liquid Tether, you need to be able to, as people redeem them, destroy the asset in some quantity. And actually, I've got a tool that tracks all of this information for every asset ever created on Liquid, knowing how much of supply was created and how much exists at any
What's
point in time.
left?
That just goes to a burn address, or?
It just does a op return, so it basically is provably unspendable. So the wallet itself will know that it's there's no
Way to spend it. Yeah.
there's no script that could ever satisfy this. So you can see here the value.
Unless it's a push.
No, we can't roll back stuff. We have the value maximum and minimum as well, but we also have the asset commitment in here. Where is it at? yeah, there's the commitment. So asset commitment. This is showing we're proving what it is without actually being part of this. So we sent the asset. We're going to do one last part of that exercise, and somehow it's scrolling like crazy.
Let me ask you a quick question.
Yes.
This get raw transaction was displaying what everybody sees.
That's correct.
But your wallet uses different code.
Yes, so if you do get transaction, it will do from the wallet's perspective. And something is holding down the mouse here, so it's going crazy. You see that?
Yeah.
What do we got here? Is it this guy? I know. I'm touching something. My mouse is just going nuts here. All right, let's see if we can get this back going in here. So the last thing to do is to reissue the asset. Let's see if I can get that up. It seems to have calmed down. You gotta use keyboard shortcuts, right? All right. Laptop is totally going crazy here. Someone hacked my, you see this?
Yeah.
All right, so the last things we were going to talk about was reissuing the asset. There's a command for that. I'm not going to be able to type it here while this laptop is scrolling everything that it's touching and moving randomly. But the idea is you just type reissue asset and it can create that as needed. I'm just going to move this in front so we can at least see something that's useful here. So if you're going through these exercises, you can actually reissue that asset. You create more of it. And if you have the reissuance token in your wallet, you can actually use it. Lawrence is going to zoom in here.
I was trying.
That's good. We call reissue asset. In this example, we used a label, which actually is also kind of in the more detailed exercises.
So when you label an asset, this is only applying locally. However, we're also working on an asset registry where people can optionally go and fetch data,
Awesome.
to labels and things like that.
All right. So the last exercises, if you do walk through those, is actually setting up the chain. So you can actually create private keys to create your own federated chain. In this case, we're gonna, in this example, we do a 2 of 2. So you generate, actually, is it 2 of 2 or is it 1 of 1?
I think it was 2 of 2.
2 of 2. And in that case, when you try to generate a block, it's going to fail. So you actually will be able to create your own federation at this point. Let's see, has the mouse calmed down from where it was before? Nope.
Try to use this instead.
It's
Well,
it's moving even when I don't touch anything. There we go. All right, back to the slides. If I can get this to play, then we're going to be good. All right, cool. So we skipped through that. The last thing we want to talk about, and we'll have time for questions after this too, is the idea of an atomic swap of transactions. So this is where we really get the power of Liquid, because we have these assets natively at the protocol level without doing any kind of smart contract. So we have Alice here and Bob, and they want to trade liquid Bitcoin for liquid silver. So just pretend for sake of argument, there's a vault somewhere, and we both trust. You want to be Alice or Bob?
Bob.
Okay, I'll be Alice today. And we both trust that this vault holds silver and that they issue shares of it. And they're audited, and whenever they create or burn this asset of liquid silver, that the auditor can actually validate that what's on the blockchain is actually correct. So if we want to trade liquid Bitcoin for liquid silver, and this is a bearer asset that we'd have at the silver storage place, we want to trade with each other. But we don't want to actually move the silver out of the vault. So we can actually do what's a single transaction atomic swap of two assets. So the idea here is, Alice, I guess that's me. I have the Bitcoin. I'm going to buy some silver, 180,000 grams of it. And Bob over here has the silver, and he wants to get some Bitcoin.
Yep. So we collaborate, and we construct a transaction that either works or doesn't. There is no middle state where I send to you the silver, but then you maybe don't pay me the bitcoins, or vice versa. Maybe you send me the bitcoins, but then I won't send you the silver. The transaction is atomic, and once we both signed, it
can be broadcast.
Executed. Yeah.
Yep. So what are the risks with this? I guess in a traditional model, if I was going to do something like this, you basically there's a couple ways you could do this, right? You could have a single transaction. If we had two different chains, we'd have to both lock up our funds, make sure that they expire too far in the future. If the conditions are wrong, maybe he can pull his funds back. But with Liquid, it's all or nothing. So what happens in Liquid that can go wrong? Well, I could construct this transaction and have it ready to go, and he could refuse to sign it. So if we had a handshake agreement that, yeah, we're going to trade for this amount, he could say, no, I'm not interested at that point in time. So that's still a threat that's possible. Then you have the idea where, okay, let's say he signs it, and now I have the transaction with his signature. I can sit here and now wait to see if the price of silver goes up or not.
Free option.
Free option, exactly right. So in that case, Lawrence could invalidate the transaction by spending his silver, and now my free option is basically a 1-minute free option. So if it's an asset that's not super volatile over 1 minute, this is very easy. The other option is you could have a third party that collects signatures, and as long as you trust them to broadcast it when it gets both, which is not, they never have control of your assets, they never, can block you from doing anything with them, but they could aggregate signatures and release them onto the public. So it's a much safer way of doing this than a lot of other systems where you now have other parties. What's that?
It's not even a notary at that point. It's just sort of like a witness.
Exactly. It's just someone who's just doing to do this. So this is the last thing. Lawrence's team has been working on a tool to make this really easy in a graphical user interface, basically where you say what you have, what you want. It will send it to the other person. They can confirm it or reject it, and then the other person will go back and sign it, and it's broadcast. So this is going to be the kind of a next little tool. Look for that to be released probably in the next week or so.
Probably, yes.
So
it's.
Yeah, screenshots you can show us?
I don't
think I have them on here, but I can maybe show them to you afterwards.
But it's very simple. It generates some JSON that you pass around, and it's basically a front end to Liquid
UX
RPC.
is not easy, like selecting the right assets and how much you're trading for and against and stuff like that. So.
Yeah. So we got some. I can dig up some screenshots, but not easily. Okay. So we have what, 15 minutes? Or no time. We're done.
Yeah,
Why did I think we were going to 12:15? I'm not. All right.
Quick question. Is the asset is it like, can it also be like true LUC assets?
Absolutely. You do have to have, if you do a swap, you do have to have someone pay a fee.
Or like
For the fee.
But other than that,
Yeah. You can swap silver for gold.
But someone has to pay Liquid Bitcoin as a fee to the miners. All right.
Thank
I
you.
think that's all the time. Thank you.